Download this code from codegive.com, link in the description below. Troubleshooting failed to compile bytecode locally errors, a comprehensive guide. The failed to compile bytecode locally error is a common hurdle when developing and deploying applications, particularly in contexts like serverless functions, example AWS Lambda, Google Cloud Functions, Docker containers, or environments with strict dependencies. It essentially means that a tool attempting to precompile your code, usually Python or node.js, into bytecode is failing. This bytecode is often meant to optimize the execution speed in the target environment. Let's delve into the reasons behind this error, provide detailed troubleshooting steps, and offer code examples to illustrate common issues and solutions. Understanding bytecode compilation. Before diving into the specifics, let's clarify what bytecode compilation is and why it matters. Source code versus bytecode. Your code, example python.py files, javascript.js files, is human-readable source code. To be executed by a computer, it needs to be translated into machine-understandable instructions. Bytecode is an intermediate representation of the source code. Think of it as a more optimized and platform-independent version compared to raw source code. The compilation process in languages like Python, the Python interpreter automatically compiles source code into bytecode, .pyc or .pyo files, depending on optimization settings, when it's imported or run. However, certain deployment tools attempt to precompile this bytecode locally before deploying to the target environment. Benefits of bytecode. Bytecode compilation can speed up execution. The interpreter doesn't have to parse and compile the source code every time it runs. Reduce package size. Bytecode files can sometimes be smaller than the original source code. Obfuscate code. To a limited extent, bytecode isn't directly readable like source code, making it slightly harder to reverse engineer. Why failed to compile bytecode locally occurs. The error failed to compile bytecode locally suggests something is interfering with the compilation process during the build/deployment phase. Here are the most frequent causes. 1. Missing dependencies. Python *. Your code may rely on external Python packages that aren't installed during the build process. For example, you might use requests or NumPy in your code but haven't included them in a requirements.txt file or installed them in the build environment. Node.js*. Similarly, missing node_modules are a major culprit. Packages not listed in package.json or not installed during npm install/yarn install can cause compilation failures. System-level dependencies. Some packages may depend on system-level libraries, example a C library required by a Python extension. These libraries need to be present in the build environment. 2. Incompatible Python version. The Python version used during the build process might not match the version expected by your code or the target environment. This can lead to syntax errors or incompatibility issues with certain packages. For instance, your code might use features introduced in Python 3.8, but the build environment is using Python 3.6. 3. Incompatible node.js version. Similar to Python, node.js version mismatches can cause problems. Packages might depend on specific node.js versions or have compatibility issues with older versions. 4. Platform-specific dependencies. Some packages, especially those with native extensions, are compiled differently for different operating systems, example Linux, Mac OS, Windows. If you're building on one platform and deploying to another, you might encounter issues if the compiled bytecode is incompatible. Docker containers can introduce platform differences. If you're building outside a Docker container and then deploying inside, the build environment's platform may differ from the containers. 5 Build environment issues insufficient permissions the build process might lack the necessary permissions to write to the file system or install packages. Limited resources, memory, disk space compilation can be resource intensive. If the build environment has insufficient memory or disk space, the process might fail. Corrupted build cache cache dependencies or build artifacts can sometimes become corrupted, leading to errors. 6 Faulty code while less common if the code runs fine locally, syntax errors or other code problems can prevent bytecode compilation. This is more likely to occur if the code being compiled is different than the code you are using to test. 7 Tooling issues problems with the specific tools used for deployment, example serverless framework, Docker, specific CI/CD tools, can also cause compilation failures. Outdated or buggy versions of these tools can be the root cause. Troubleshooting steps, a detailed guide. Here's a structured approach to diagnosing and resolving failed to compile bytecode locally errors. 1. Examine the error message carefully ****. The exact error ***. The full error message usually provides clues about the cause of the problem. Look for specific error messages related to missing modules, syntax errors, or platform incompatibility. File paths Note the file paths mentioned in the error message. This will tell you which files are causing the compilation to fail. Stack traces If a stack trace is available, it can help pinpoint the exact location in your code where the error originates. 2. Verify dependencies, the most common cause. Python requirements.txt Make sure you have a requirements.txt file in the root directory of your project that lists all required Python packages. Use pip freeze requirements.txt to generate this file from your working environment, after you've installed all the necessary packages. Install dependencies During the build process, run pip install r requirements.txt to install the dependencies. If you are using a virtual environment, activate it first. Specify versions It's often a good idea to pin package versions in your requirements.txt file, example requests == 2.28.1, to ensure consistent builds. This prevents unexpected behavior due to package updates. Node.js package.json ensure that your package.json file accurately lists all the required dependencies in the dependencies and dev dependencies sections. Install dependencies run npm install or yarn install during the build process to install the packages. Package lock.json or yarn.lock commit these lock files to your repository to ensure consistent dependency versions across environments. Check node_modules While you usually don't commit the node_modules directory to your repository, verify during the build process that it's being populated correctly. 3. Address version incompatibilities Python specify Python version explicitly specify the Python version in your build environment, example in your Docker file, CI/CD configuration, or serverless framework configuration. Virtual environments use virtual environments, VNV or virtualenv, to isolate dependencies and Python versions for each project. This prevents conflicts between projects. Node.js Asterisk specify node.js version asterisk use .nvmrc or .node version files in your project to specify the required node.js version. Tools like NVM, Node Version Manager, can then automatically switch to the correct version when you're working on the project. Asterisk Docker file asterisk specify the node.js version in your Docker file. Asterisk engines in package.json asterisk use the engines field in your package.json file to declare the supported node.js versions. 4. Handle platform-specific dependencies asterisk asterisk. Asterisk Docker containers asterisk the best way to manage platform differences is to use Docker containers. Build your application inside a container that matches the target environment's platform. This ensures that dependencies are compiled for the correct operating system and architecture. Asterisk multi-platform builds asterisk if you need to support multiple platforms, you might need to use conditional dependencies or build scripts that install different packages based on the target operating system. This is more complex and should be avoided if possible. Asterisk precompiled binaries asterisk some packages provide precompiled binaries for different platforms. If you're using such a package, make sure the correct binary is being used for the target environment. 5. Investigate build environment issues asterisk asterisk. Asterisk permissions asterisk ensure that the build process has right access to the necessary directories, example for installing packages or creating bytecode files. Asterisk resource limits asterisk monitor the build environment's memory and disk usage. Increase the resources if necessary. Asterisk clean build asterisk clear the build cache or perform a clean build. For example, in Docker, use the -no cache flag when building the image. In CI/CD, look for options to clear the workspace or cache. 6. Review your code for errors asterisk asterisk. Asterisk syntax errors asterisk double check your code for syntax errors, typos, or other common programming mistakes. Run your code locally to identify these errors before deploying. Static analysis tools, linters, can also help. Asterisk logical errors asterisk while less likely to cause bytecode compilation failures directly, logical errors can sometimes indirectly lead to problems, example an infinite loop that consumes all available memory. 7. Examine tooling configuration asterisk asterisk. Asterisk serverless framework asterisk review your serverless.yml file to ensure that the correct Python or node.js runtime is specified and that dependencies are being packaged correctly. Asterisk Docker Compose asterisk check your Docker Compose.yml file for any configuration issues that might be affecting the build process. Asterisk CI/CD configuration asterisk verify that your CI/CD pipeline is running the necessary build steps, example installing dependencies, running tests, and that the environment is configured correctly. Code examples and specific scenarios. Let's look at a few specific scenarios and how to address the failed to compile bytecode locally error. Scenario 1. Python with a missing package in AWS Lambda. Asterisk problem asterisk you have a Lambda function that uses the pandas library, but you haven't included it in your deployment package. Asterisk solution asterisk. 1. Create requirements.txt asterisk. Ensure pandas, and its correct version, is listed in the file. 2. Include in deployment package asterisk use a deployment method, example serverless.yml, that includes requirements.txt and installs the dependencies. 3. Deployment script asterisk ensure the deployment script runs pip install our requirements.txt before packaging. The T flag ensures that packages are installed into the current directory so they can be included in the Lambda deployment archive. Scenario 2, node.js with native modules in a Docker container. Problem You're using a node.js package with native modules, example a package that relies on C++ code, and the compilation is failing inside the Docker container. Solution 1. Ensure build tools are present. Install the necessary build tools inside the container, example GCC, Make, Python. 2. Use a base image with pre-installed dependencies. Some node.js base images, example Node 16, already include common build tools. 3. Match architecture. Ensure the Docker images architecture matches the target environments, example Linux/AMD 64 for Linux x86-64. Scenario 3, Python version mismatch in Google Cloud Functions. Problem Your Cloud Function is configured to use Python 3.7, but your code requires Python 3.9 features. Solution 1. Specify Python version explicitly set the runtime in your functions.py file to the correct Python version. 2. Ensure local environment matches use a virtual environment with Python 3.9 when developing and testing locally. Best practices to prevent bytecode compilation errors use virtual environments always use virtual environments, Python, or manage node.js versions with NVM to isolate project dependencies and avoid conflicts. Lock dependencies use requirements.txt with pinned versions, Python, package lock.json or yarn.lock, node.js, to ensure consistent builds across environments. Specify runtimes explicitly define the Python or node.js runtime in your deployment configuration, example serverless.yml, Docker file, Google Cloud Functions configuration. Use Docker containers to create consistent and reproducible build environments that closely resemble the target environment. Test thoroughly. Test your code in the target environment, example a staging environment, before deploying to production. Automate builds. Use CI/CD pipelines to automate the build and deployment process. This ensures that all the necessary steps are executed consistently. Keep dependencies up to date. Responsibly regularly update your dependencies to benefit from bug fixes and security improvements. However, be cautious about major version updates, as they can introduce breaking changes. Test your application thoroughly after updating dependencies. Monitor your applications. Monitor your applications for errors and performance issues. This will help you identify problems quickly and prevent them from affecting your users. By following these troubleshooting steps and best practices, you can significantly reduce the likelihood of encountering failed to compile bytecode locally errors and ensure a smoother development and deployment experience. Remember to carefully examine the error messages, verify your dependencies, and match your build environment to your target environment. Good luck.